Alright folks, so we're going to build a 555 circuit. We're going to build this one here. And a 555 timer is a little tiny thing. You should have one or two of them inside your kit. I laid them loosely kind of in your bucket. They weren't inside the cardboard box. So there's a little tiny thing. They look like this. It has 4 pins on each side, so a total of 8 pins. And they always jab right here in the middle. So we're going to attempt to make one and see if it works in Tinkercad. And the first thing I'm going to do is I'm going to assume that battery is, where is it? I lost my battery. Let me go back here. Basic. And let's go to battery right here. And we're just going to assume that, let's say, notice the little notch here, right here? The notch. That's this one right here. And positive goes on the upside, VCC. VCC is positive, by the way. So we're going to do positive up there. So I'm going to kind of crisscross these wires a little bit, which I don't usually like to do. And in fact, actually, you know what? I think I can actually just rotate it around so I don't have to crisscross. I don't like to crisscross. I just got this button on accident. So let's see if I can just rotate this thing like that. And we'll just hook them up on this side. So, and that's totally fine to do. So this is the positive, we're going to hook it here, and the negative, we're going to hook it here. And the first thing we're going to do is we're going to deal with this. Notice that pin 8, right here, it says VCC. It's called VCC, but it's pin 8. This is shaped differently than this, and that's why this is what it looks like in real life. This is what it looks like in software. So pin 8 and pin 4, they connect together and go to the positive, right here. That's what the positive 5 volts looks like right here. So we're going to send VCC pin 8 and pin 4 and send them both to the positive. They're connected together, but they're connected to positive, so it doesn't really matter how you do that. So that's pin 8 right here. We're going to send that to the positive. And pin 4, which is right here, is also connected right here to the positive. So we're going to connect, is that pin 4 right there? I just got to double check. I think it's this one right here actually. So this one's connected to the positive. How you go about doing that, if you, in real life, you'll probably just get lazy and run it right there, okay? You could do that, okay? That's totally fine. If you want to make it look pretty, you can do it like this. So electricity travels from this row to here to this row, then to the positive. So that's the more professional, pretty way to do it. So that was pin 4 right here. Remember the notch is here? And that was pin 4. They both connected to the positive. Next thing is we have a 1K resistor. And one side connects to the positive. The other side connects to, well, this, yeah, but really, what does it really connect to? Follow that wire. It connects to pin 7. So right next to that VCC. And that's a 1K resistor, a 1K resistor right there. So that's from here to the positive. So that's going to be easy to do. We just take this, and that's it. And it's already 1K. Look at that. It's already 1K, and it's connected to pin 7, which is here. It's called discharge. See, they even tell you what it's called, discharge. Let's just double check. Right here, DIS, discharge. That's pin 7. You can double check here. Pin 7 is discharge. There's the notch. Yes, that's it. And so we did it. So this one is done. In fact, I'll show you what, if you could do this at home, I would prefer that you do something like this. So you go here to desktop. No, that's not the one I wanted to open. Hold on. Open this one. So I'm going to resize this. Resize to, let's say, 1000. And resize the image. Yep. There we go. This is a little blurry. I should have downloaded a better version. But what I do is I put lines through the ones I connected. So I did these. I connected as a positive. I even did this one right here. And I did this wire, kind of. I did this wire. Kind of, I say, because I better do this one right away before I forget. This is another resistor, and it connects one side to pin 7 as well. And the other side connects to, it's hard to say, right? It connects to this, but let's ignore that. Where does it really connect to? Pin 6 and 2. And 6 and 2 are connected together. So let's do, first thing we do before we forget, let's do the 6.8K. And so we need a 6.8K, and it connects to pin 7 right here, and we got to rotate this. Pin 7, so right here, and the other side's connecting here, but let's see where it's supposed to go. So one side's connected to pin 7, yes, that's where that goes, and the other side leads to pin 2 or 6. It doesn't matter which, because they're both split, in other words, they're connected together. So 2 or 6. So right now I'm here, I moved over here somewhere, and I'm going to go to 2 or 6. Technically, we could actually just connect it at a weird angle right here if you really want to save wire. Let's see if we can do that. It's too long on here. So I'm going to, one's connected to pin 2, pin 7 right here. And the other one connects to right here, I do believe, or is it here? I'm going to double check real quick. It connects to 2 or 6, which means it connects right next door, or to 2. So that's the second one over. So I'm going to connect it over to here, and then from here to here. Oops. I got to go in a different row. So from here to here. So now it's connected to 7 and to, what is that? To 2. This is pin 2. But remember, 2 and 6 need to be connected together. You might lazily just do that, like make wires go over it, and you shouldn't do that though. It's really ugly. But really, how else would I do it? Well, I know how I can do it. This is pin 2 right here, here, here. That's still pin 2 because it's all leading to here, correct? So really, I just need a wire to go from here to here. That will do it technically because that connects pin 6. Remember, it's 1, 2, 3, 4, 5, 6, 7, 8. So 6 connects to 2. I just need to connect them together. But technically they are now because this is connected to here, which is connected to here, which is connected to here. So that is working. So I can go over here and say that I am done connecting this guy. This guy's done. I did this wire. This one I connected to pin 7 already, and the other side I connected it to pin 2. 2 and 6 are connected together. That's what that wiring I just did was, right? Now I have a capacitor that's a 100 microfarad, and one side connects to ground, so and the other side, so the negative, so ground, and the other side connects to 2 or 6. It doesn't matter which, right? Because they're connected together anyway, so it connects to here. I can also connect it to here, which is also connected to 2 or 6. It doesn't matter. So I'm going to connect it to 2 or 6. It doesn't matter which one. We'll keep this simple. So let's get a capacitor. Here's one right here. Perfect. And what was it? It was what was the value on it? It's a 100 microfarad. Actually, this is an electrolytic capacitor. I think if we have one in our kit, it's going to be electrolytic. I wonder if they have electrolytic capacitors. Let's see. I don't think so. I think here just a capacitor is a capacitor, which is fine. In your kit, it's not going to look like this one. I'm just letting you know. Now, one goes to 2 right here, and the other one to ground. So sometimes it's possible to bend this wire over to here. So I won't be able to do that because it won't reach. So what I'm going to have to do is say, okay, pin 2, you're going here. Actually, let me delete that so it looks a little prettier here. Pin 2 is going here, and then this leg is going to go to the negative. So now I have a capacitor, and I have 2 parts of it here and here. One is going to negative, and the other one is going to pin 2, because remember it's pin 1, 2, 3, 4, 5, 6, 7, 8. Here's a notch. So 2 and negative, did I do it? Yes, I did. So I'm going to go here. I'm going to say, yes, I connected one leg to negative. I got a wire that's going there. And the other one I sent it to 2 right here, which is connected to 6, and that's all good. So that's done. So this is done. Now I need a 0.1 microfarad. Let's fix that too. That's 100 microfarad. So let's fix that. I think I have to change it. 100 microfarads right there. So that's done. I need another capacitor. Where's it going to go? Between pin 5 and ground. So here's ground and pin 5. There's even a ground symbol there. Pin 5 and ground. So here's pin 5. and here's ground. No, sorry, pin 5 and ground. So let's go do that now. Pin 5, 1, 2, 3, 4, 5. So it's going to go here. So I need one that jabs in here. So look, I jabbed it directly into that row. So pin 5. The other one's going to go to ground. So how can I go to ground? I guess I could just run one all the way over here. I hate crossing wires here because they don't connect, but if it connected there would be a circle, but there's no circle there. So that's done. So if I can go over here and cross that off my list, I did this. I connected one to pin 5. I literally stuck this leg directly in the hole next to this one. And the other one I ran a wire all the way down to the ground, so that's done. Pin 1 needs to be connected to ground. That's going to be easy. I'll do that right now. That's easy. Pin 1 right here. This is pin 1. There's nothing connected to it yet. It's connected to ground right there. Easy. So I did that one. And the last thing I need to do is just put an LED. With a resistor, it doesn't need to be a 470. I don't think we have a 470. Let's use a 330. It doesn't really matter. All that does is protect your LED. So that's on pin, I think that says 3. That's the out. So pin 1, 2, 3. And that makes sense. This is the last one that doesn't have anything. So let's get an LED. And the positive side needs to face that way. So let's rotate this thing around. Oh, go back around again. Alright, so the positive is going to come from here. Oh, but first the resistor, right? So let's move this even further. Let's put the resistor. I wonder if we can just put the resistor directly in there. That's what I would do if I was like doing it myself. I'd probably just stick the resistor directly in that hole connected to pin 3 and make sure that this resistor is regular ohms, and we'll use a 330. And technically the positive power will come out. It'll come here, and we could even maybe even I'm going to move this actually. We could even stick this light directly here. Remember, this is the positive leg right here, and that's where it's going to come from. This positive signal is going to come here, and the ground is always going to be right here. So look at, you see I have these two holes, one for the positive signal from here and one for this hole right here that's going to be negative, and I just plug them both there. And that's it. I have no idea if it's going to actually blink. I don't see any blinking going on. Maybe these simulators don't work in blinking world, you know. But that's pretty much it. If I make a mistake, I'll let you guys know, but I think this is the correct way to do it. So here's the two mistakes I made. I just paused the video and went and tried to figure out if I made a mistake. And just to give you a heads up, this is actually going to work. This is pretty cool that this has a bunch of internal components that makes this all work. This 555 timer, it's an integrated circuit. It's integrated, it has all kinds of transistors and stuff in here. So the only two mistakes I made was this one. When I laid this one here, I forgot to change it to 6.8K. Remember right here, it says it was a 6.8K. I forgot, it just stayed 1K. The other thing is I forgot to change this one to 0.1 microfarads. So when I laid this one here, I forgot to change it. So I put 0.1 microfarads right here. And that's it. So this thing's ready to go, and I just push simulation, and because we're building a 1 hertz circuit, that means it should blink once per second. Something like that. So let's check it out. It actually works. This is insane. I have no idea how they do this. This is like a really cool processing thing that's going on. It's simulating this perfectly. That's pretty neat that it can even do that. So this is working. So yours should do the same. So all I need to do is see that you have this circuit set up. I should be able to see that these colors are matching correctly, and it should blink for you. If you produce a video of it blinking like this, pretty cool too. But you can just give me a screenshot of it, and I'm cool with that.